Hello everyone, it's Mr. Salimata over here, and today we'll be looking at the Pythagoras theorem and how we use it to solve the missing side in a right triangle. And by the end of this lesson, every student should be able to use the Pythagoras theorem to solve the missing side in a right triangle. So I'm sure right now you guys are asking yourselves, say, why is Mr. Salimata only talking about the right triangle? Well, the Pythagoras theorem has to do with the right triangle and the relationship between the sides. Now, talking about the sides, let's take a look at our right triangle over here. So the longest part in a right triangle is the hypotenuse. So I'll just label that over there as hypotenuse. Yes, and the hypotenuse is opposite to the right angle over here. Yes, the hypotenuse is opposite to the right angle. And now the remaining two sides, which are shorter than the hypotenuse, these two sides are the legs. So I'll label this part as the leg and label the other part over here, or the other side, as the leg as well. Okay, so then how do we find our missing side over here? The Pythagoras theorem states that the sum, yes, the sum of squares of the legs equals the square of the hypotenuse. Now, that's a lot to digest, right? So then how about we transform the words into an equation? Yes, and how do we do that? So let's do that by labeling our sides of this right triangle over here. So how about we give the longest part over here, which is the hypotenuse, let's label that as C. And let's give this leg over here, or rather this side over here, as A. Yes, let's label it A. And then this side over here, or our other leg, let's label it as B. Yes, okay, so now if you remember, I did say that the sum of squares of the what, of the two legs equals the what, the square of the hypotenuse. So then this side over here is A, so that would be our A squared plus, I'm using the plus sign over here because we're talking about the sum of squares of the two legs, and this other leg is B, which is our B, which is going to be our B squared, equal to this, the square what? The square of the hypotenuse, which is C squared. Okay, so there we go. This equation over here is what we use to find the missing side of any right triangle. So all what we have to do now is to substitute the length that we have already. So A squared over here, we know our A value there is what? Is 4. So that would be what? That would be 4 squared plus, sorry, allow me to just erase that, plus, yes, plus our B value is what? Is 3. So that will be 3 squared equal to C squared. Yes, okay, so now 4 squared gives us what? Gives us 16 plus 3 squared gives us 9 equal to C squared. So now let's try to solve our left side of our equation. 16 plus 9 gives us 25 equal to our C squared over here. We just leave it, or rather write it like that as our C squared. Okay, so then let's try to now isolate C so we can get rid of our exponent over there, and we do that by square rooting it. Yes, so let's square root this side. Now remember, because this is an equation, what we do on this side we have to do on the other side as well. So we also have to square root the other side. And what's the square root of 25? The square root of 25 is equal to 5. Yes, and this other part over here, the square root and the squared over there they cancel. So that leaves us with C. Yes, okay, so there we go. We have now found the missing side in this right triangle over here. Now there's something that I want to note before we look at this other question over here. It doesn't really matter on how you place or where you place your A and B on the legs. Yes, so you can place your B over here, or you can place your A over here. As you go down your calculation, you still arrive at the same answer. Now let's not make a mistake. I'm talking about the legs. I'm not talking about the hypotenuse. So the hypotenuse, you just have to leave it the way it is, which as we have right now denoted as C. So you leave it the way it is, or you can only swap the legs over here. Okay, so this can be your B, this can be your A, or this can be your A, and this can be your B. Yes, okay, all right, so let's move on to this other question over here. Okay, okay, so now looking at this right triangle over here, remember we did say that the side opposite the right triangle over there is what? Is the hypotenuse, right? And remember, I didn't mention that when it comes to the hypotenuse, we don't have to change it, right? So let's leave it, or rather, let's denote it as C, okay? So this side and this side, it doesn't really matter on which side you choose to be A or B, right? So for me, I'll take this as my A, and then I'll label our missing side over here as my B. All right, okay, so we already know the equation that we are supposed to use. If you remember, it's over here, yes? So which is A squared plus B squared equals to C squared, right? So A squared plus B squared equals to C squared over there. And we already have our C over there, so our C squared will be what? 17 squared over there. And our B is our missing side, so we don't know that part. Our A over there, which we already have, is 15 squared, right? Okay, so now let's find the values of 15 squared and 17 squared. So 15 squared is what? Is 225, yes? So 225 plus B squared, and the value of 17 squared is 289. Okay, there we go. So then the next step for us is to isolate B squared. And how we're going to do that? We'll do that by subtracting 225 over here. Now remember, this is an equation, so what we do on our left side, we have to do it on our right side as well, right? So we do the same by subtracting 225 on the other side. Positive 225 minus 225, those two cancel, and that leaves us with B squared over there. And 289 subtract 225, that gives us 64. Now our next step would be isolating our B over here, and we will do that by what? By taking the square root, so we can get rid of our exponent 2 over there. So square root, yes, remember what we do on this side of the equation, we have to do it on the other side as well. So we take the square root that side as well. Sorry, I didn't write that. Okay, that nicely, yeah. Okay, so now the squared over here cancels with the square root, and that leaves us with B, and the square root of 64 is what? Is 8. There we go. So we have found the missing side over here, which is 8. Yes, okay, so thank you so much for watching this video. In our next video, we're going to be looking at more examples on how we can find the missing side in a right triangle.